Good evening and welcome to this, the fifth TACK talk, part of the series of a broader research project on the nature, role, and modalities of tacit knowledge in architecture, or of what we know but cannot verbalize or put into an explicit framework. In these talks, which we have now already had 4 of, architects involved in this network present and discuss their work, and the researchers involved respond to their presentations. My name is Lara Schrijver, and I will be moderating this evening. And tonight we have Stefan Rutzinger and Christina Schieniger of Soma Architecture in Vienna presenting their work, and Paula Strunden of the Academy of Fine Arts in Vienna responding. First, our lecturers for this evening, Stefan and Christina, are founding partners of Soma, an Austrian practice that has worked on a wide range of international projects, including award-winning competition entries, innovative cultural buildings, and urban master planning and social housing, as well as exhibition design and installations. In addition to the theme pavilion for the Expo 2012 Yosu in South Korea, they have completed projects such as the traveling art pavilion for the Salzburg Biennale and the Austrian headquarters for the German firm TACK. Stefan and Christina have worked together since 2007, and their work combines high aspirations towards design together with technical and structural feasibility. And they work towards figuring out advanced and complex structures and their sustainable implementation. The team's work has won numerous prizes and awards, and they have been figured in significant exhibitions, such as the Venice Architecture Biennale, Archilab 2013, and they have also exhibited at the Museum for Applied Arts in Vienna and the Tallinn Architecture Biennale of 2019. Both of the partners are teaching. They used to teach at the TU Wien. They have taught at the Bartlett at the Unit Masters, and they are currently teaching at Innsbruck. And we're very happy to have them here tonight to explain some of the work that they have been doing, particularly since the name of the firm it refers to the idea of the sentient body, which immediately suggests the kind of unverbalized knowledge that sits at the very core of the research in this network. So with that, I would like to give a warm welcome to Christina and Stefan and ask them to turn on their video and share their screen to present some of their work.
Okay, thank you for the introduction, Lara.
Okay. Okay, I think we are there. Thank you, Lara, for the introduction. Thank you also for the invitation to have us here at this TACK Talk online lecture series. And also I have to say that we are very excited to be part of this research network, which is investigating tacit knowledge in architecture, and we are very much looking forward to explore that also with all members. As Lara already mentioned, that our name refers to the sentient body. I think for us it was always important to refer also to the human body as a scale, or let's say a scale for architecture, but also as the sentient body, that it is the notion of the sentient body which describes how we engage with our built environment, with our senses. Let's say what kind of role form and space, color and pattern are playing, but also more ephemeral qualities, or let's say atmospheric qualities like sound and light, even material and material performance, especially when it comes to movement, is something which interests us a lot. And but the question, or the key question is, and this is what we like to show a little bit, how we put all these qualities and pieces together into one design process, and how we negotiate, let's say, also these kind of qualitative things with a more pragmatic framework, which also is part of architectural design. Now, therefore, we usually have very common techniques like the deductive or inductive techniques, like say bottom-up or top-down strategies, which is very common. But there is also a third approach to that, namely the abductive. And in our understanding, that means that we approach a certain situation or observation or phenomenon and try to come up with an educated guess or come up with ideas how to complete this observation. And this in our office happens very often in comparison with 3D sketches, or like you see here in this example, a loose set of lines, a vague formation of lines which are not interconnected, which are let's say very vaguely describing something, but are highly charged with qualities. And through let's say bringing to these sketches additional readings and ideas, we are able to extract various projects from those vague sketches. For example, here we see a very direct translation. We just turned the lines into small geometric tubes, which are aggregate and introduced a fabrication technique. In that case, it was 3D printing, in order to get a tiny art piece out of it, which is now part of the Benetton collection. But a very similar set of lines, we put movement, and in particular rotational movement of the individual members, and we were able to come up with a design for a small pavilion for the Neue Oper Berlin, an experimental space for contemporary music. And in fact, you see that here these rotational acoustic panels are let's say now changing the not only the acoustic qualities, but also the visual appearance or the visual effect, which became a synesthetic experience for the visitors. On the other hand, like taking the let's say the component-driven design method further, we see that in that case we were looking very into structural performance, at the same time coupled with the visual appearance, and we wanted to achieve a flickering mass for the design of a mobile art pavilion for the Salzburg Biennale. And therefore, let's say we had to negotiate this structural integrity of this structure together with aesthetic qualities, and therefore we introduced the evolutionary process to negotiate these two criteria with each other through fitness criteria. And you see on the right hand side how that process were dealing with those criteria, and in the end we were very happy with the result, as you can see here on a photo on site, that this pavilion in fact came together as a kind of wake formation of components, a flickering mass, which make people curious about the inside and what is going on inside. At the same time that the material or the chosen material became also very relevant. The reflective tubes were catching, or pipes catching the colors of the surrounding in order to make a kind of contextualization. You imagine that this pavilion was not only set up in one place, but was traveling also on rural areas. As a kind of further development of this idea, we also introduced the notion of material performance or material systems. What you look here is a really small sample of zigzag lines which holding together only because of its special geometry and by material friction. And the idea was to carry out with this system summer pavilion for the 21er Haus, which is a museum of contemporary art in Vienna. So we studied role models, in particular Feld, as a role model for that, where you have this kind of linear and fiber-like elements which through the curling geometry and through the material friction are holding together into kind of bigger structures. And we investigated that also in digital studies, but to be honest, we soon found out that it is necessary to come up and test this in one-to-one mock-ups because the material performance was not we could not well describe in the digital model. So what we did basically, we did a lot of these one-to-one testings and mock-ups in order to come up with really big with big prototypes, but also then looking at it, how big or how well we could build the proposed summer pavilion. In order to understand why these individual members are really holding together and how the forces are going through the structure, we also did some small simulations together with the structural engineers. And finally, we ended up with this kind of design where you can see we created a very soft structure, but a weak structure, one could say, but stable enough to build up towers up to 9 meters. We were able to reach spans or arches up to 5 meters, where, let's say, the wind was going through, but weak enough so you can imagine the swaying of the towers while still people were observing and enjoying the summer pavilion. Now, these kind of these were all, let's say, some samples how we develop designs from let's say component-driven concepts. Now I would like to show also that quite small examples. Now I would like to show how also bigger structures and bigger designs can develop out of such ideas. in here, for example, we investigated how particles, let's say, are a set of particles which is aware of each other, let's say, and rendering a certain behavior together are studied, and by tracing those set of particles we are able to deduce let's say certain structural but also design ideas, aesthetical design ideas, which then have been transferred into the tower structure. And you can see how in some areas the traces are dense and combined into strands, while in other areas they are unfolding, and you are able to inscribe function and program into those areas. But I think the most interesting part and striking part was in the end that we were able to develop an open tower structure with open cross sections, which as a direct translation of the traces of those particles, which in the end we were able to also prove that this open tower structure is catching much less wind, and in that case it was up to a third less wind loads we could simulate, and that means also a third less of the material you would need to build the tower, which also would mean a third less cost, which then was invested into the special construction, the special appearance and form of the tower, but also in a whole variety of energy, alternative energy concepts which have been applied to the tower. So at that point, I would like to hand over to Christina to do the second part of the talk.
So Stefan was talking about the kind of speculation that's always ongoing in the office. So we really proceed certain topics and interests, and then we investigate the potential for projects or for implementations that arise from them. And since I think it's also what we gained as an experience as architect, that it's very useful if the design systems that we use are malleable. So they're kind of weak. So they have a certain principle, but still they have the tendency to transform and adapt easily. And of course, these what Stefan called guessing, or this adductive idea that there is primarily the idea of discovery. This method also requests a lot of trial and error and a lot of building of variations. And here you see only a snapshot of all the models we did for the competition for the theme pavilion. And you see how these volumes are aggregating and transforming and connecting and separating. And in the end, it's always important for us that we have these poles. We have the principle of the kind of a little bit you could call it also the essential idea that you can communicate and that it's immediately understood. So for here, it was really this vessel that has the vertical orientation and is able to transform into the horizontal. But then there's also this bandwidth of transformation that you can explore, and also further during the design and building process, you can adapt to the changing requirements and constraints within a project. So this idea, we like to enrich these ideas a lot. So we like when things become productive in a spatial, organizational way, also in a structural way. So as you can see here, this one idea organizes the main spaces in the building, the main exhibition spaces, and also the lobby. It separates them and connects them at the same time. And also we have the design system of these interconnected types that were first in a regular grid, and then while they transformed, they were always interdependently changing and altering each other. And then of course we like to test a lot. This is, for example, a twin type that we then have a closer look at, and also then we always like to evolve ideas. For example, how could that then help to develop a circulation and this immersion of entering and exiting the exhibitions. But of course, also always we like a lot the idea of the concept model. So the model where these ideas synthesize and still are very expressive of the intent that we have. So you see here how this aggregation of the originally 7 volumes turns into these 6 volumes, where one gets a platform and the other one gets big because the function and the interior program changed during the course of the project. And also on the other side, how we like to negotiate these systems. Here we have the cones that are later on made out of concrete, and we have the steel structure and the kinetic lamellar facade, and how these two systems are negotiated with each other. That's something where we really find it very useful to have these reduced models. They might be digital, but also physical from time to time. The kinetic facade was actually a very challenging part of the project, and I think it was where probably the guessing came into play at most, because when we were envisioning this facade, this seamless swaying facade that moves without a visible cause, we were really not sure how we would be able to build it. And we teamed up with Knippershelvig Advanced Engineering and developed together, we can really say, a novel facade. So the novelty is that it is dependent on material capacity. So the movement, the geometry, the material, the choreography, all together create a synthetic whole. And actually, therefore, the facade became a very efficient way of opening a kinetic device. You can see on the left-hand side the model, paper model, that by Knippershelvig, that explains the very simple principle very well. So it's really a little movement that happens at 2 of the edges of the lamella, and then because of its elastic characteristics and properties, it's GFRP, and also due to the L-shaped cross-section, so it's stiffer on one side and more flexible on the other, it buckles. And buckling is usually something that you want to prevent in architectural elements, and here it becomes the actual motor, so to say, of the movement. And it was really great to see then that this movement without a cause was really creating something like a wonder for people. So some people started applauding when they saw these 15-meter long lamellas suddenly opening up and these material bending out of the pavilion. And for us, it was just proving that architecture has extremely strong central means. And compared to all these LED light shows that were taking place, and you can see we also have the LED spots on the facade too. But compared to those, this physical movement and this material bending out was a much stronger sensation. Yeah, that's then the pavilion, how it was built at the water break out into the open water in the expo aerial. So these geometric operations, as we call them, are very, for a very long time, very crucial for us. So they were really an important tool to define this kind of idea, this basic idea, and then create these variations and then test what in between spaces, what effects, what types we could generate out of that. So this is a competition entry that we did for a Taichung library. But also, as you can see here, another competition entry for the Kinmen port terminal. Again, here we were interested in creating something that's between water and land, and when you would appear it would almost seem like a water body, very translucent and even almost like a weak form again. But if we, and now we show you how we worked, or what the backbone of the project was. in the beginning, we of course look at constraints a lot, also at organization, at spatial requirements. We read the brief very carefully, but we also communicate, as I guess most architects, through visual images a lot, because these vague ideas are for us often really end up in a collection of words and images, and in these images there's all this implicit design knowledge embedded. And of course, since we work together now for almost 20 years, we share a lot of our visual memory also. So this ping pong is even much more immediate. But when you come to, so it's easy to formulate these ideas and easy to find the imaginations or the visual images that you have in your head and share them. But when you want to translate them to the model, it's actually a very tedious process. So you look for certain rules that can be deduced, you test if you can reproduce the effects. And this is really an iteration of different translations. And in the end, you end up with something that we always feel has not the richness of the original images anymore. So it tends to lose the vagueness, it tends to lose the openness. And also you have to decide for a geometrical carrier, you have to decide for software. So in this case, it was always these single surface projects, or also NURBS modeling. And so we got a bit also tired about losing always this complexity. And so we were really lucky that just now we were starting a big research project. It's a special research area together with the TU Vienna, the GCD, the Center for Geometry and Computational Design, which is in the lead, and TU Graz. And as you can see, we're a team of architects, engineers, computer graphics, mathematics, and informatics. And we're working, so we are a research cluster working on several areas. Our sub-project is embedded in design methodology. We also have projects working on the visual and haptic design interactions, on the immersed designer, if you wish, that has now different tools to interfere with design. And also we have projects working on materialization, evaluation, and form finding. And our project is called computational immediacy, because what we are trying to develop in the next 4 years, and hopefully it's going to be prolonged to 8 years, which is possible within that program, is we're working together with the Institute of Mathematics, and we're deploying neural networks, machine learning, to retrieve implicit design knowledge that resides in objects. So the idea is that we create a simple workflow that later on can be extended into a bigger early design stage workflow where the designer can state certain explicit constraints or design decisions, and then he literally picks images and mixes them, and what the network that we are developing with the mathematicians does, it retrieves 3D point clouds from its own visual memory that we feed him with, of course, and suddenly the designer gets that suggestions of 3D objects already and does not need to do that translation. Now, of course, this is a very ambitious project. We're aware we started actually 2 months ago. We're super excited, and I think it's also what all our different poles between the geometry and the idea to go beyond geometry brought us to, and now it's really interesting to do that now in a research setup. We also would like to show you, let's say, the recent speculation that we ourselves immersed ourselves into. This is also what we showed at the Tallinn Biennale, and we were very lucky and happy to collaborate also with Paula Strunden there. She did the VR representation, so to say, of a part of our project there. And it was really interesting to see your own work through somebody else's eyes and also device. And this is just probably a first idea what it could become spatially, or what the qualities could be, or the materials. that it might get, and also maybe fabrication, maybe it's woven. So we really like to, yeah, even indulge a little bit in these qualities. We enjoy that very much, and we like to keep these things open. And of course, we now looking forward to also connect that back to the idea of machine learning and this retrieval of implicit design knowledge in objects.
Yeah, and also the materialization later on.
And then a direct materialization. So the idea is really that while receiving these point clouds, we will also find a way that you can then directly print them and fabricate them. So the idea is really to get rid in a way of geometry, get beyond geometry or this geometrical determination, and really create an open design process where you can, during this early design phase, can still get in completely different direction as a designer. So that was it.
Thank
Thanks.
you.
Thank you so much. That was lovely. It's wonderful to see not just the images that one sees on, say, when the architectural photography is done or the projects, but to see these processes of the algorithms that you're showing as well. Now I'm going to let you two catch your breath for a moment while I introduce Paula, who will be asking the first round of questions this evening to start off the discussion. Paula Strunden is an architectural designer. She's kind of based in between Amsterdam and London, and she's co-founder of Soft Bodies and the educational XR program Virtual Fruits. She studied at the Academy of Fine Arts in Vienna and the ENSAP Paris program before graduating from the Bartlett School of Architecture. And she has experience working for Archithese, Raumlabor, Herzog and de Meuron. Now, her strength is exploring the imaginary spatial potential with the virtual and mixed reality environments. As an associate of STORE, Paula has led a series of VR workshops at cultural institutions in London and abroad, and tutored at the Bartlett School of Architecture and the Architectural Association. Her work has also been exhibited at a number of different design and film festivals, such as at the Royal Academy of Arts, at the Estonian Museum of Architecture, and at in Amsterdam. So I think actually the match between the one work and the other is good for tonight. So Paula, may I ask you to start the discussion from here?
Thank you very much, Lara, for the nice introduction. And yeah, thank you so much, Christina and Stefan, for the amazing lecture. I think it's such a joy to see more of your work and really understand the projects. And I think especially also all the research that goes, that flows into it, what Lara said about understanding the processes behind it. I think what I wanted to ask, or to start with, is I'm particularly interested in your office's relationship between the academic and the practical work that you managed to do. And I think my question would be how this relationship has developed throughout your career, and how do you decide when to put your energies where, and what is driving your decisions in between the two, and if you even make a differentiation between them. This is just an assumption, of course. Yeah.
I think at the beginning, it was like that we did a lot of, let's call it research for now, but it was more like investigations about testings and trying to be curious about certain things. And that was done within the office. We just did it on our own. And but on the other hand, I have to say that from the beginning, having an office, we always were teaching. Yeah, we always had a kind of relation to universities and contact to students as assistants or as external lecturers or something like that. And so at the beginning, we did a lot of this research within the office, and then bringing that back to the academic field and to the students and see what they do. But it's a little bit like a pendulum. It sort of it goes in one direction, then it swings back into the other, and this kind of thing is still continuing. So I think at the moment we have, of course, a lot of research done on the academic side, and there is some, but not so much in the office. Yeah, but as I say, I think this is still a swinging thing. Yeah, it swings forth and back.
I think also in the office, sometimes you really need to be quick and spontaneous, and you have to have a deadline, or you have to pay people doing these things, and that's good because it really forces you to be innovative and efficient in a way. And the academia, I have to say, the prospect of following now an idea for 4 years, and the chance, if we perform well, then we could do it 8 years, is a completely strange horizon, right? What would you do with a project throughout 8 years, right? So it's interesting that, but on the other hand, I think it's probably also why we went also then into academia and decided also to really, because first it was, I would say, 90% office, 10% academia, and now I would say it's the opposite, right? It's a lot of academia and far less practice, which is also pity sometimes, but on the other hand, you gain this freedom, and that is really, wow. I mean, it's cool. Yeah, I think that's.
And I have to say, it also, it is not, I mean, we try to do that whenever we did a project within the office. Yeah, we always try to have this kind of innovation pick in the project, or let's say the research aspect embedded into a project. But it is an enormous amount of effort to come up with new ideas. I mean, the example of the expo facade is a very good one, because drawing up the competition, yeah, and handing in the idea, yeah, was easy, because it was just a few lines and the text, which was describing what it should do. But then executing it and convincing engineers, the clients, and all kind of the officials and so on. It was super problematic, and we were also very lucky that in the end it got executed, it got built. Although we did all our tasks we had to do in order to make it happen, still it was very uncertain. And I think this is now, when we do research now in the academic field, that is on a much, let's say, more secure ground. Yeah.
May I jump in for a moment, Paula? Because I'm kind of curious. Paula already kind of got you talking about research, but you were also talking about teaching. And as you were explaining things, I was also wondering if you ever find that there are kind of similar iterations between what you're thinking about as a designer and then how you're communicating it to students. How does that work? Is it?
I think it's pretty much the same approach, that we motivate students to really go into these exploration and find what they like and explore and trust their guts in a way. So, if they bring their drawings, you say, you made that drawing, now have a better look, even if it's not yet that great, what do you think? But there must be an interest. And I think the best results are always when students really get that excitement. And I think that's what you need as an architect, right? Because if you don't have the energy and the engagement, to really fight that through, because I agree with Stefan, if you really want to build it or find a client, you need to be very convincing, and you can only be convincing, if it's your own piece, right?
Yeah.
You need to be honest in a way, because in the end it's put down in numbers and money, and it's very difficult to cheat in architecture, I think, because it's there in the end. It's not the rendering anymore. So I think we it's really making them confident in their own tools, but we are not so much the methodological guys, so we like to have individual projects. But I think this the idea of the testing and the exploration first, and then see the potentials, and then understand where could it go. That's something that we have totally, and we do a lot of one-to-one here in Innsbruck, a lot of prototyping and building, and using the material. Also, students a lot of developing new kinds of materials, observing material behavior. And I think that's also, I see that there's a huge interest at the moment in the younger generation in sustainability in an aesthetic and creative way, so that they really, at the moment we have projects that deal with cellulose and how to print with cellulose. And so I think it's at the moment we have a very interesting young generation here that's very responsible, but also wants to be really creative and is confident. And then I enjoy working with these young generations now.
I've actually been going through your CVs and speaking about generation. So I realized, kind of as yourself, and I think also the majority of PhD students within our network, I feel that we are kind of more and more running through quite an international education and training in architecture. And I personally always saw that like full of chances, but then finishing my studies, also realizing that it's full of challenges, because architecture continues to be a very local discipline that relies on regional laws, regulations, networking very strongly as well. And I was wondering maybe if you could elaborate a bit on the benefits and challenges that you have experienced within your UK, Austria transnational background, but maybe also the projects that you've been doing in other countries.
Actually, it was not so different, I have to say. Because
it is
nice to hear.
All the traveling is also very tiring, and honestly, the lockdown was also a big relief. In that sense. But
I think there's always been a very strong. So wherever we went to London, we went to Los Angeles, and it's always because there's this Austrian connection to London, to the Bartlett in specific, to Peter Cook, and also Yale Reisner, and then there's a connection also to UCLA SCIARC from the applied arts. So I think we probably did that too little, going off the road, going to completely different places. I think we stayed very much in this network in a way. This Austrian, American, Anglo-Saxon network of certain, let's call it experimental architecture maybe, or and I think it's not an accident that we ended up in Innsbruck, which is also part of that very much. There are many alumni from the applied arts now here, and there's again people from the Bartlett, people from SCIARC. So it's actually, I think, really weird that we are so connected internationally, but then still we're all in the same world in a way, right? So I don't know. That's at least my experience. But I think that for sure, we studied such a long time, right? And now everything got much quicker. And I think this whole university system at the moment really, I think people just go somewhere for a year and then they come back. I think also that speed sometimes is not so good. I think we studied for 8 years, then we hang around another 10 years. We did some competitions. It was also a bit easier to survive from scholarships that we got, and yeah.
Paula,
sorry, I'm a bit. I'm just not sure if I should react or ask more, but
continue the conversation wherever you want to take it.
I think I will leave that there, and I'll ask something else that is maybe more like also in relationship to the work that I do, or like where maybe there are parallels in our approach. I mean, this of course also is of course due to the fact that I come from that network that you just described too. So yeah, but I think it's really nice to see, because I wasn't so aware of that. And I think also when you're like, yeah, younger as a student, you just go through it, but you're not maybe as reflective to that amount, and you only realize later that, okay, they actually hang together, they know each other from way back then. And yeah, so I'm still in the mode where I'm interested in diving deeper into it. I think like what I wanted to ask you also, it's relating to the name of your office, what Lara mentioned at the beginning of the talk when she introduced you, and also what you were speaking about is this idea of the sentient body. And I think it's something that also in my experience working with virtual and mixed reality, I'm really interested in understanding a bit better, like how you manage to marry this idea of the perceiving body and this like highly subjective experience with the digital tools that you're then using. And I think especially as you also go into like robotics and more like building modeling, and or like even, I don't know, might be calling it parametric modeling. And yeah, I was just wondering like where you see that relationship between the body and the tools you employ, and the outcomes that you develop through them. I think maybe just one thing I really liked in your talk was when you mentioned that visitors were applauding when the facade opened, because I think it's this amazing, like, so intuitive, direct response to such a sophisticated high-tech happening. And I don't know, maybe like, I think that's already hinting a bit maybe in the direction, but if you could just elaborate a bit more on like where you see that relationship between the technologies you're employing and then this very embodied understanding of architecture.
No, I don't know. I think it has more to do with the experience you have as a designer, or with the intuition you have as a designer, whether your final result relates to the senses, or how it relates to the senses, or if it really lives up to the imagination you had for design, or piece of architecture. Then the techniques or the technical devices you're using. So far, at least the devices we were using were not really, let's say, helping us on that topic so much. It is much more our imagination and our experience and our take on certain things, what we like to achieve, and then whether we use a parametric software package or robotic lab for production or something like that.
I would also agree. I think that we very much see these things as tools that help us to produce something. And then I think the sentient body has almost to do also with the kind of a brain wavelength that you're entering by designing, right? That you're not you're not too much the logical guys that like to really construct and then count, and we very much we get into this mode where we really start to perceive also and engage with what we do, and then I think it doesn't matter so much if you hold the mouse in your hand or the pencil. It rather depends if that what you did and what you're then looking at talks to you, right? So it's really this communication that happens, and that's bodily. I mean, in terms of that, it's not always these logical or these measurable thing. That there's something, where, I mean, it's very also sometimes really emotional. So that we have certain ideas that haunt us. I mean, I know when Stefan did his diploma, he said, it needs to dissolve, right? And then everybody's like, dissolving architecture, that's really bad. You can't dissolve architecture. But he wanted to do something so light, and in the end, he ended up with like an aggregation that was very cloudy. And I think that yeah, it's just this imagination, as you said, or this feeling. So we really start a project with kind of a mood or a sensation, and that's probably why we call it Soma.
maybe through the SFP, the research project we are doing now, yeah, we just started. Yeah, we probably get also a different take on the question, because this would basically, I mean, basically we are working on a workflow there, on a new workflow for a design method, and this would allow also, let's say, unexperienced designers to step into the world of designing three-dimensional objects. And the question is how much this kind of workflows could support them in order to get something out of a certain quality, or not. Yeah, maybe it's also not like that. Yeah, this is
well, I mean, I'm intrigued. I'm very intrigued because I noticed a few times also in your lecture that you were very outspoken about intuition, speculation, imagination is the word maybe that you would add now. And in a way, it's interesting because if I think back to the beginning of tools such as what you're working with, then you would have to explicate everything, right? You would have to be writing lines of code. But I do imagine that the tools themselves are shifting enough to allow more intuition to come to the surface. Would you talk a little more about what you're finding over the course of 20 years in those tools?
I totally agree. I think the problem is still the mastery of these things. If it starts to block you or even frame you or cage you. And I think that's why we try to look for something so basic, right? That you can literally say cloud, fiber, and suddenly you would at least have something there and be able to explore it, right? And I mean, I don't know if we will really achieve that it becomes that intuitive or immediate, but I think if you know, if we need to connect the brain and the computer somehow. It needs to be really become our tool. At the moment, I think that we kind of, I mean, these modeling frameworks often restrict us, but then they also, you know, all these idea about evaluation, optimization, they try then to they try then to convince us that what they trapped us into is then even the best result.
Yeah.
Right?
Yeah.
I think that can't be that we as architects throw our thousands of years knowledge, our disciplinary knowledge aboard, and then we believe some optimization algorithm, which we all know it's senseless because it's not even multi-causal, right? So it's really just linear. So I think architects, we have such, and then that's also why we immediately said yes when we were asked to join TACK, because I think it's exactly this knowledge that we have to negotiate, to sense these things, and we need to make tools that help us and support us doing that. Absolutely.
At the very end, I think it's always more interesting to talk about the picture instead of talking about the brush.
Yeah, but to get there, you do need to be able to make something, to create it. And I mean, maybe if I could just ask you to talk a little bit about your relationship with your structural engineers, because there was a thing you said really briefly, you said, well, then we have those structural engineers. And I was wondering, because I can also imagine that maybe their position is like, I can imagine their eyes getting big when you come with a new plan. And I can imagine maybe equal parts of exasperation, like how are we going to do that, and fascination, like I wonder if we can make that work. So how does that relationship work?
We were very lucky that we got from early on. We got in touch with very good engineers, namely Bollinger Kroman from Frankfurt. They also have a
I noticed
in Vienna.
He was
and he was our professor at the university. Yeah, so we were in good hands from the very, very beginning, and they supported us even after finishing university and setting up our own practice. They were very supportive until now. Even now, when we do realization projects with the students here in Innsbruck, I can call up and ask them to look over our geometry models and stuff like that. And I think this is a very lucky situation, because some of the projects we have done wouldn't have been possible without the input and the engagement of the structural engineers. They have a really big part of those projects, of the success of the projects also. And that also has to do a lot with, let's say, trust, because when it comes to consultants and consultancy within architectural projects, it's sometimes also very difficult. And if you know each other very well and you know how, yeah, I think that is a good situation for fruitful collaboration. And just like the Salzburg pavilion I was showing with the aluminium profiles, I mean, they had such a huge part in that design process. So I think also talking about authorship, I think it's not even clear where the line goes, which kind of ideas belong to the engineers or the architects. It was really sort of completely intertwined or entangled.
It's even the agenda is shared suddenly, right? Because the design, if there is a design sensibility on the side of the consultant, right? And well, things happen, and I think I totally agree with Stefan. I think this discussion then about authorship becomes totally senseless. We should rather talk about the common understanding and less about what is mine and what is yours.
We are running close to 7 o'clock. Paula, would you like to maybe have one small final question? There have been so many points raised, of course, but...
I don't have any particular question now, but I think I'm just really looking forward to this collaboration. I think like everything you spoke about, and I think especially all these terms like trust and intuition, and they are very much, I think resonating also with the approach that I've been taking. And I think that's not it's not the norm, I think, especially when working with these kind of tools. So I think, I'm just really looking forward to our collaboration, and excited of what's going to be the outcome. And I think, especially seeing that you're kind of diving into these research projects where nobody knows what's going to come out. This is very exciting.
And on that note,
a little bit of a surprise. You always have to save a little bit of a surprise or adventure, because I think we would not sit here today if we would have done what we know. We always do some stuff we don't know or we don't.
I certainly think in this era of trying to always know what you're going to get at the end of a path of 5 to 6 years, I think it's excellent that we have a little space for play. I want to thank all of you very much for being here. I love the work you shared. I look forward to having more talks like this. Paula, thank you also for posing the questions that allow the conversation to continue. I think it's going to be a marvelous adventure in the coming years. I would also like to remind our audience that next week we will have another TACK talk. That will be with Jan de Velder, the well-known Belgian architect. It will be moderated by Christophe Grafe, and Jonas Sklavounas will be responding and asking the questions. And we hope to see you then again next week. And thank you very much to all of you.
Thank you.
Thank you.
Bye-bye.
Bye.